Hi. So, let us discuss the agenda of today. Today, I would be discussing everything about design pattern, why it is important, what are the cons of it, and why you should learn it. So, let us move forward. So, what is basically a design pattern? So, let us first take down this statement itself. So, let's say this is the new project of Noida, and I have been given the responsibility to lay down the roads, the drainage system, and the other linkages, like where would be these all electricity lines on itself. So if you observe that instead of me going out in the home and then sitting and then thinking what to do, where to do, and how to do, I would just call up my friend who has already done that, and then I would just ask him, like, what should be done. Remember this, what should be done. Like, what needs to be done, I'm not asking it. Why? Because he's not here and he has not done the same project, but he can give me an idea how to do it. Okay, like he would give me a blueprint that yes, if you talk about drainage system, it should be towards the borderline of the road. Why? Because if the road gets broken, road gets like in a general fashion, road gets teared down from the middle, so that would hamper the drainage system and that would hamper the whole city. That is why you should have drainage system towards the borderline. Make sense? So he would give me blueprints to implement it. See what I'm trying to differentiate. Let me just clear down again in just 1 minute. So see, if you observe, my friend just gave me an idea how to do it. I would formulate this idea and then I would tell the workers what to do. If you observe, me after formulating and then telling the workers would be more concrete, but what my friend told me would be an abstract idea that needs to be implemented, formulated, whatever it says. So this is what is design pattern, this idea that needs to be implemented or formulated. Okay, solution to common problems. Let's say someone has already done this, someone has already implemented authentication, someone has already implemented something that I need only one instance of it in the whole code base. So that is what singleton design pattern. So solution to common problems is known as design pattern. Now it is not algorithm. Why? Because let's say I want to find out prime numbers on a range of 1 to n. So if you observe, the prime sieves gives us a clear set of instruction that use this, like you can just copy paste the solution and you can find out the prime numbers from 1 to n. This is what, this is this one, this idea that is already formulated. Okay, but design pattern is just what my friend told me. I need to formulate it, I need to have a concrete implementation of it. Okay, design pattern is an idea, an algorithm is a clear set of instruction that is already formulated, already trial and tested. Okay, this idea is also trial and tested because my friend has already done that, but at the end of the day it is just an idea. So now let's talk about the origin of it. So if you go out the clear names or specific names, it is not important in terms of interview, neither it would be important for the rest of your engineering journey. But one important thing is that a solution to a problem, this is important, the origin of it. When this is problem 1. Let's say I want to implement authentication to a particular system, and then the solution used to it or the pattern used to it is used again and again, again and again. So someone would just take that pattern out as a template kind of thing and name it. Okay, this is how a design pattern is originated. It is not originated by someone specifically, it is not that. A solution idea gets repeated again and again, again and again, so it is someone prints it and gives it a name. Like let's say my let's say this is one person. Like, let me give you an example to this also. Let's say this is my friend. Okay, I called him, okay, to ask I called him to ask him that how to implement the drainage system. Then again someone else asked him. Now he observed that every other day some new person is coming and asking him, so why not write a blog on it and post it publicly, so that when and whenever people need it, they don't need to ask him explicitly, they can just read it from there. So to have a common standard form, just like we have OAuth 2 to implement authentication in the same manner, the standard way, so like a thing is getting repeated again and again, so they just give a name out to him. That's it. Let's move forward. Why should you use design patterns at the end of the day? See, design pattern is already trial and tested, because I told it na, a solution becomes a design pattern when it is repeated again and again. That is why I can say that it has been already tried by multiple people and already many people have given a feedback to it. Makes sense? Now, this is what is a common ground to it. See, a regular engineer who is deprived of low level design, it is a very high chances that he is using low level design, but he doesn't knows a name to it. Okay, so knowing the name to it and using it, yes, at the end of the day we just want to use it. Okay, makes sense. But see, the problem is I might use it and I might think that other people don't know it, so I would be moving forward and I would start documenting it thinking that other people don't know it. Okay, like let's say I am using singleton design pattern. Okay, I am using singleton design pattern. I as of now don't know the name. I have implemented it and then I wrote a documentation to it and explaining everything. Okay, this is wasted energy documenting singleton design pattern. No, if you know the name, you can just write it in the comments that yes, singleton design pattern is used here, and someone out there can already go, if he already knows singleton design pattern, he would be already acquainted with it. If he doesn't know, he would go and read about it and then come back. So documentation of singleton is already available, but you thought that no one else knows it, so you started documenting it. So that is why a common ground is necessary, so that you can skip explanation. Let me give you a clear example of it. Let's say there are three classes. This is class 1, this is class 2, and this is class 3. There are three methods: method 1, method 1, method 1, method 1, method 1, method 1, method 2, method 2, and method 2. And this last method is class specific. Okay, let's say this is something different, 3.1, this is 3.2, this is 3.3. So I found out that these two are common. So a common problem solver who is a good problem solver itself would do what? He would say, let us implement all this in one class, a single class, method 1 and method 2, and the last method would be overwritten by C1, C2 and C3, so that we can avoid code repetition. Makes sense? A problem solver would think in this way. So now he would document it. Okay, like he would explain everyone else. But no, if you know design pattern, you would simply say, as there is a duplicate methods, so I can simply use template pattern, template design pattern. This is what template design pattern. I don't need to explain the stakeholders that what I intend to do. This explanation part of keeping all the common function in one class and then writing the explicit function in their own class, this doesn't need to be told. Just tell design pattern needs to be implemented here and everyone would be able to do it. So avoiding the hassle of the explanation, documentation, as well as everyone has a common ground to it. Fair enough. Let's move forward. What are the cons to it? So if you talk about this, see what I taught about. See, design patterns exist in the first place to facilitate solid principles, to respect solid principles. Make sense? Now, solid principle facilitates what? See, at the end of the day, the design patterns respect solid principles. Solid principles talk about testing and scalability. Now see, if you observe, that a very small or a early stage startup, which is an experimental startup, even though it is a production grade code, at that point of time, writing so extensible code is unnecessary amount of work that needs to be done. Fair enough? Like if you see in real life, a very early stage startup who is started by a founder, they don't have testers, they don't have any lower level engineers, they are the one who are working alone. So a very small scale code doesn't needs to be scalable enough, testable enough. One more, this is one example, a very early stage or a very small scale startup. This small scale code doesn't needs to be done in this way. One other case, let's say I am writing a script to find out all users who have a graduation year greater than 2023, to just run some campaign or something. So if you observe, the primary focus of our script is to just take out the data, and there is a very rare chance that I would need some heavy modification over it. Make sense? So that is why using design pattern for just a one-time script or two-time script is unnecessary. So a very important con of design pattern, which is applicable to every design pattern, is over engineering. That sometimes just we know design pattern, so we are trying to implement it, but implementing design pattern takes an amount of time, and if that amount of time is more crucial than the extensible code, amount of time should be more preferable. Then the very next point is that few of the design patterns, when they were found out and given a name and termed as design patterns, at that point of time the programming languages was not that much capable enough or easy implementation enough. For example, the lambda function, which is introduced in recent times in most of the programming language, just like Python and then Java. So if you observe, earlier lambda function didn't exist. So people found out a way to implement lambda function and named this as strategy pattern. Okay, so now if you see in real modern programming languages, we don't really need strategy pattern. We can just use lambda function to implement strategy pattern. So some of the patterns that doesn't needs to be done, the modern programming languages already does this for us. That's it. Now that you know what are the cons of it, what is and why and how, let us also know as what are the different types of design pattern. If you talk about object oriented programming, what are the things to it? We have objects and we have classes and we have different methods, how it is, what needs to be done. These are the components of it. So see, the creational design pattern deals with the creation of objects. Okay. The structural design pattern deals with how it is structured itself, like what are the different methods to it, how it is inherited from the different classes. Then the very next thing, which is very important, see, at the end of the day, objects interact or communicate with each other, because a single class and its object won't solve the whole purpose. We have a different set of composition that solves a big problem. So that is why we have behavioral design pattern, which deals with communication, which is very important for us. So that's it. Now we would start unwinding first creational design pattern, then structural design pattern, and then behavioral design pattern one by one. And now the frequency of the videos would increase to a great extent. That's it for today. Thank you and have a nice day.